Hello my dear students, welcome back to NEET WORLD. So we are discussing hydrocarbons right now. So in the last sessions we have covered alkenes and also some portion of alkynes chapter right now. So in this session we will be covering the remaining portion of alkynes chapter, then we will be looking into the previous year questions of these hydrocarbons from EAPCET. Okay. So after that, in the next session we will be covering aromatic hydrocarbons like aromaticity and how can we identify aromatic, non-aromatic compound. Those things will be in the next session. Okay. So now let me show you a few questions, just like verify whether yourself, like whether you are able to solve these questions or not, because these are some previous year questions asked from hydrocarbons in EAPCET exams. Just look at here, we have a question like this and like this, and here one more question. So these are some questions, just cross verify like whether you are able to do these questions or not. If you are really able to do this, it's really good. If not, I will suggest you to watch my previous live sessions. Okay, so where I have covered discussion of these questions. Okay, now in this session I will be bringing up few more questions. Okay, in this session I will be bringing up few more PYQ questions from our discussion itself. Okay, so once after completing this, you can just take any previous year paper of this EAPCET or NEET or JEE related to these topics, I mean hydrocarbons, and you can solve those questions without having any confusions. Okay, right. So the next here we will be giving you the new topic here. Just hold on, let me check whether everything is clear here. Yes. Yeah. So after these, just look at these questions. Yeah. So now from the discussion, previous discussion, tell me what could be your answer for this question. See, it's very easy. They are asking the decreasing order of acidic nature of the following compounds. So how can you answer this? Tell me. Just give me your explanation for this. The decreasing order of acidic nature of the following compounds. Acidic nature of the following compounds. See here, acidic nature of alkynes is due to presence of hydrogen atom that is present on this alkyne carbon. On what carbon? Alkyne carbon, that sp hybridized carbon. Okay. So now that kind of hydrogen is present in first as well as in second compound as well as in third compound right now. So now what do we mean by acidic nature? This H plus ion should come. It means whatever the sigma bond electrons are present here, that should stays with the carbon only. Only H plus ion will comes out as a proton right now. So this proton is coming out. So more easy to liberation of that H plus ion, greater is its acidic nature. Now it depends on the group attached to that alkyne substituents. Okay. So now here you can see on this phenyl ring we have a nitro group. This nitro group is considered to be electron withdrawing group right now, whereas here like NH2 group is there. So these nitrogen lone pairs are in conjugation with this ring electron. So I can say this is a strong ring activating, like electron releasing group it is. Okay. So now there is no such group here. So whenever we have electron withdrawing groups, that will increases the acidic nature of organic acids. Okay. So it means H plus ion comes out here easily. Therefore I can say wherever we have electron withdrawing group, that organic acidic nature will be more. Okay. So it will be more for 2. So acidic nature is more for second one, and the next here electron releasing group is there now. So that will decreases the acidic nature of carboxylic acid. Okay. It means the least acidic is this electron releasing group, that is 3 at the least, and in between there is no such groups. So it will be in between 2 and 3. So I can write 1 in the middle. Okay, 2, 1, 3. So 2, 1, 3, your option C will be a perfect answer for this question right now. So now I will be making one more question for you. Just practice it and tell me, like based on the same explanation, what is that explanation I am saying? If electron withdrawing group is present, acidic nature of acids increases. Acidic nature increases. If electron group withdrawing group is present, acidic nature increases. If electron releasing group is present, acidic nature decreases, acidic nature decreases. So based on this, you just tell me answer for these two questions. Here I am attaching cyano group, cyanide, CN, and the next one here I am attaching here one alkyl group, CH3, and here you have hydrogen. Okay, and one more example I am giving, 1, 2, and third one here. Yeah, so 1, 2, 3, these are the 3 examples. Tell me which is more acidic here out of this 1, 2, 3 options, which will be more acidic based on your understanding. Whatever we discuss now, based on that, you just tell me what is your answer for the question. Okay, right. The next one here is one more question I will be showing on the previous discussion. See, arrange the following in the correct order of their acidic strength. Again, this is a PYQ question of EAPCET. So how can you answer this? See, whenever there is a triple bond, it will be having carbons, sp carbons right now. So sp carbons, hydrogen attached to that sp carbon will be more acidic when we compare with the sp2 and sp3. Therefore, you can say second one is having sp hybridized carbons, okay, and here third one also having sp hybridized carbons having one nitrogen. So out of these two, one will be more acidic, but which one? See here, whenever electron releasing groups like alkyl groups are there, its acidic nature relatively decreases. Okay, therefore there is no such group. So 2 is more acidic, after that 3, and after that here you have carbons with sp3 hybridization, and here you have carbons with sp2 hybridization. So where do we have more acidic nature? sp2, because it is more electronegative now. So 2, 3, 1, 4, 2, 3, 1, 4. So this will be your answer for the question. So 2, 3, 1, 4, 2, 3, 1, 4. So option B is your answer for the question. Hope this discussion is also clear now. So is there any confusions here? No, right? Right. So the next thing is here is, look at this. This is also question from yesterday's discussion, like hydrolysis of alkynes in presence of mercuric sulfate, okay, or in acidic medium. So this will be giving us carbonyl compounds. Especially I told you all alkynes, like all substituted alkynes, alkyl group containing alkynes like internal alkynes gives ketones, okay, whereas only acetylene, that is what ethane will give acetaldehyde, whereas other alkynes gives ketones. Okay, so now look at this, what is the compound given here? CH3H4. It means 3 carbons. It is propane, na? 3 carbons means propane. So it means, see, how do you got this is a propane or not? See, find its degree of unsaturation. For example, given compound compare with the alkane. So what is an alkanes here? C3H, CnH2n plus 2 is the formula of alkane. Okay, but this is not following that rule. I mean, this is following this CnH2n minus 2 kind of rule. Let us check once what is the formula it is satisfying here. CnH, if I write H2n plus 2, right? So 6 plus 2, 8 it should be. Okay, it should be 8, but it is only 4. How many hydrogens are less here? Here it is less by 4 hydrogens now. If 2 hydrogens are less, 1 degree of unsaturation, but 4 hydrogens are less means 2 degree of unsaturation. So 2 degree of unsaturation is nothing but you need to insert 2 pi bonds in the given formula. So like that I can make a formula. See here, CH3, C, like sigma bonds are over. The next 2 pi bonds should be inserted now. Yes, one more. Okay, that's it. Now out of 4 hydrogens, 3 are over here, 1 more hydrogen I am writing here. Therefore all carbon valencies are satisfied right now. So this is how you need to construct the chemical formula. Okay, you need to construct the structure from the given chemical formula. So now this one undergoing hydrolysis, it means you need to add H and OH. So where this H, OH will be added onto this carbon, that is what the question here. See, whenever we are adding something like H plus and OH minus, whenever you are adding an electrophile like H plus or any other electron deficient site, so that should be goes to this terminal carbon, okay. So that should be goes to this terminal carbon like this. After that, so if these pi electrons are disconnecting with this carbon, so on this secondary carbon you will get a positive charge right now. So there you add this OH group, okay, like this, so that you will get CH3, C double bond C, already one H is there and new hydrogen is coming, so I am writing that here, and here OH is coming, that you can write it as OH like this, okay. So this is our X, so this is our X in the given question here, okay. And this is undergoing tautomerism. Tautomerism means what? 1,3 proton transfer right now. So here hydrogen is there now, so this hydrogen will transferred from this oxygen to this carbon. See, just count the carbon to hydrogen, oxygen, 1 2 3, so 3 now, so 1,3, so from first position to third position proton is getting transferred, okay. So that you will get a product like this, CH3, C double bond O, CH2 and this hydrogen CH2 and that new hydrogen coming here, so that is also hydrogen. So that is nothing but acetone right now, CH3CO CH3, that is nothing but acetone, okay. What is it? Acetone. So acetone is a ketone, right? So look at the options, where do we have acetone here? See what they are asking, X and Y are, so Y is our ketone, yes, here and here ketones are there. And the next one, they are saying it is unsaturated alcohol, X is unsaturated alcohol or X is saturated alcohol, they are saying. See, one pi bond is there now in the given X compound, so it is unsaturated compound. So it means unsaturated alcohol is our X is our unsaturated alcohol and Y is our ketone. So what could be your answer for the question? Second option will be unsaturated here and ketone. So what could be your answer? Third option will be perfectly correct for the given question right now. So hope this is also clear. Yes guys, if these things are clear, just click on the like button. Right, next thing is we will be giving you few more questions. First of all, tell me, is this clear or not? Guys, tell me first of all, is it clear or not? Yes, I hope it is clear. If this is clear, just click on the like button. The next question here, this is also from yesterday's discussion. See, given alkyne is treated with a Lindlar's catalyst, okay. So partial hydrogenation is taking place. So partial hydrogenation product is what? Alkynes, upon treating with Lindlar's catalyst, you will get a cis alkenes right now. So you just write C double bond C, and whatever the alkyl group here, it is ethyl, this is methyl. So write ethyl and write methyl here. The next two hydrogen should be on same side like this. So you got a cis alkene here, and similar product you will get here as a trans. Whenever you are treating with sodium in liquid ammonia, we can call it as Bruch reduction right now. So this is a trans. So both of them are alkenes, but our P is a cis alkene and Q is a trans alkene. So option C is your answer. See, all these questions are like previous year questions only, okay, right. Next, can you answer me this question, which of the following reactions is not correct? So they are saying some of these options are not correct, we need to choose that not correct one. So what could be your answer here? See, which of the following is reaction is not correct. So how can you identify this? Look at here, so zinc is there. So zinc is there here, again here also bromine is there, so two bromines and zinc. So it will comes out as a zinc bromide na ZnBr2, okay. So if it is coming out ZnBr2, so here if you are consider you are removing this is a bromine radical, here also bromine radical, otherwise zinc will be added here like this also you can consider ZnBr. When zinc is reacted with this, so you will get ZnBr and then next CH2Br. So now what happens, this bond comes here, so Zn and this Br goes out as a ZnBr2, so you are going to get a pi bond here. So this reaction is perfectly correct. Okay, it is giving alkene, ethene is perfectly correct. Next, just now we discussed alkynes with liquid ammonia, sodium metal, so it will be a trans product. Yes, trans alkene is formed here. Then next, can you identify third reaction whether is it correct or not? Guys, here again see what I told you, whenever there is a terminal alkyne, so on this terminal carbon we need to add hydrogen, and this internal carbon we need to add OH right now. So this what kind of alkene is formed here? So it will be CH3 C double bond C H, one hydrogen here, one OH here, like this enol is formed. So this enol will undergo stoichiomerism and leads to form a ketone type of product, CH3COCH3, this kind of product. But what they have given here, aldehydic product is given. So it means, is this correct? No, right? So option C is incorrect. That is what we need to choose our answer for the question, because they are asking not correct. So which is not correct? Option C is not correct. So you need to choose C as your answer. Next, what about final reaction here? Option D here mentioned like benzyl bromide. PH CH2 means phenyl group attached to the CH2 group, okay, and this bromine is there. So you are treating this with sodium in dry ether condition. Now what happens, tell me? So this will be breaks into homolytic cleavage and radicals are generated. Those radicals whatever generated will combine with themselves and gives a coupled product like PH CH2 CH2 PH. Okay, so this is our perfectly correct. Now this is also perfectly correct. See, PH CH2 twice PH. So it means D is also correct. Which is not correct? Only C. Okay, right now is this clear or not? I hope again this is clear. Right now, right. Let us move forward. Look at this question. What they are saying? Propane was subjected to a reaction with mercuric sulfate and dilute sulfuric acid, which resulted in a product P. The product P was heated with barium hydroxide to the barium hydroxide to give the product Q. The molecular formula of product Q, very easy. Do not worry about lengthy, like it is giving complete data for us. So do not think that if the question is looking very lengthy, do not scare by looking at it. Just read it, try to understand it. So first of all they are saying propane, write the structure of propane. Write the structure of propane. CH3, CH3, CH3C, triple bond C. Okay, so this one propane, this propane, see propane was subjected to a reaction with sulfuric acid like HgSO4 and dilute sulfuric acid, Try to write the reaction first. Okay, so which results to form a product P here. The product P was heated with barium hydroxide. This is heated with BaOH twice. Okay, BaOH twice. Okay, to give product Q. So what it is giving? Product Q. Okay, the molecular formula of this product Q they are asking. What is the molecular formula of this product Q? So it is very easy. See, what is this product formed here? So alkynes treating with dilute sulfuric acid and HgSO4. This is nothing but addition of hydrogen and OH, that is water molecule we are adding. So just now previous question also same thing we have did. So where do we need to add? Hydrogen here, OH here, so that you will get a carbonyl compound here first of all. So you are adding H2O now. So add H here, OH here, so that you will get CH3 COH double bond CH2. So this is your first of all enol type of product which undergoes keto-enol tautomerism and produces CH3 C double bond O CH3. So this is your P. What is this? This is your P. Okay. Now this P is treated with barium hydroxide. So barium hydroxide, what happens with barium hydroxide? See, barium hydroxide is a base, right? So that base abstracts a acidic proton. Where do we have an acidic proton in the given compound? So just look at here, these alpha hydrogens are acidic. So carbonyl compounds having this alpha hydrogens are acidic. So that acidic proton is taken by this base. Okay. So let us take one base like BaOH twice we are taking now. So from this a base abstract this proton and generates a carbene anion CH3 CO CH2. So like this we will get a conjugate like carbene anion formation. Okay. So alpha hydrogen is abstracted and forms a carbene anion like this. Okay. So this carbene anion will attack on the one more carbonyl group. I will tell you that is a simple aldol condensation, but I just wanted to give you the reaction first, then I will tell you the trick also. Like this. So now here it will be attacks here like this, so that you will get CH3 CO CH2 CO minus CH3 and CH3. This kind of product will be formed and here hydrogen will be added like this. So beta hydroxycarbonyl compound is produced. So this upon elimination of water by heating like this OH and this acidic hydrogen will be removed, so that you will get alpha beta unsaturated carbonyl compound. Like this you will get the product. So simple, whenever we have a ketone carbonyl compound having alpha hydrogen, what to give this, how to give this final product, just see here. I am taking 2 moles of this product formed P. So we got our answer, but I just wanted to add one trick to get this question. This is aldol condensation. So from one carbonyl group you take oxygen, from other carbonyl group you take 2 hydrogens out of these 3. So that you will get CH3 CH3 and this C is attached to this carbon and CO CH3. See what are the product you have written here, same as this one, no? So this is alpha beta unsaturated product. Okay. Now how many carbons are there in the given product? See 1 2 3 4 5 6. So 6 carbons are there, hydrogens are 3 plus 3 plus 3 9 plus 1 10, C6H10 and O. So C6H10O is our answer for the question. So we have here option D as C6H10O, na, that will be your answer for the question. Okay, right? Is this clear? Deepak Saini, hello dear. Is this clear? Deepak, is this clear whatever we are discussing? Right, if this is clear, just mention clear in the chat box, so that I will mention one more question here. Just try from yourself, based on the previous explanation only I am giving you. So this gives A. So just identify A. What is this A formed here? So after this, tell me whether A shows positive haloform test, or negative haloform test. This is an extra question I am adding here by linking the carbonyl compound formed as a product to this haloform reactions. Okay. So if you get this answer A as your product, then you can get to know what exactly like haloform test. Then from that you can tell me whether it will give haloform test or not. See, if the compound formed here is having methyl group, carbonyl compound with one terminal methyl group, then you can say it gives haloform test. This is a clue I can mention. So based on this you just tell me your answer in the chat box. Okay, right. The next thing is, let me give you few more things here. Look at this question. In the following reaction, C is an aromatic compound. They are only saying C is an aromatic compound. Okay, and having substituents D and E. So in this compound C, the final product C is an aromatic compound having substituents like D and E. So they are asking what is this DE in the given reaction for this substituent. Okay, very easy. So look at the given substrate first. So substrate contain how many carbons? 1, 2, 3, 4, 5, 6. 6 carbons in the main chain and one substituent, methyl group as a substituent. So whenever you are treating this with chromium trioxide as Cr2O3 at this particular temperature and pressure, so this 6-membered chain will undergoes aromatization. Right now what happens? Aromatization. We discussed about aromatization. So 6 carbons in the parent chain now. So 6 carbons containing aromatic compound is what? Our benzene now. So benzene is formed here as A, and on this we have a substituent now. So 6 carbons are cyclized, aromatized, and here you have one methyl group like this. So what is our A here? Toluene is our A. Okay, like this we got our A. So A is treated with KMnO4 in basic medium and followed by hydrolysis. So now what happens is, whenever you are using this oxidizing agent with aromatic benzene having substituents, like any carbon present here and that benzylic carbon, if hydrogen is also present, at least one hydrogen is present with this carbon, so that converts into carboxylic acid, completely oxidizes to carboxylic acid. Okay, at least one hydrogen should be present, but we have 3 now, definitely converts into carboxylic acid. So when you treat this with KMnO4, okay, so this is your B here. Okay, so this B treated with concentrated nitric acid plus sulfuric acid, H2SO4. See, concentrated sulfuric acid and nitric acid, this combination will generate an electrophile. That electrophile is NO2 plus, because sulfuric acid is stronger acid than our nitric acid. Therefore, here in this particular conversion, sulfuric acid acts as acid and nitric acid acts as a base. Okay, so from nitric acid remove OH and from sulfuric acid remove H. Okay, further it will be giving nitronium ion as a electrophile. These are the statements to be remembered during your exam, because there is a JEE question asked from this only. Okay, so how this nitric acid is formed and what is the acid and base during this reaction. Okay, remember these points. Okay, so now this NO2 will be attacks on this benzene ring. So where it will goes? So NO2 is an electrophile. So electrophile will be directed to the meta position on this phenyl ring. Why? Because in this benzoic acid we have carboxylic acid now, which is ring deactivating withdrawing group, electron withdrawing group. Therefore withdraws electrons from ortho and para position. So relatively more electron density is present at meta position only. So nitro group will be directed to this meta position. So you will get a meta substituted product here. So here you will get a carboxylic acid, here you will get a nitro group, that is it. Okay. So where do we have COOH group? Yes, COOH group, D is our COOH group and E is our nitro group. Yes, here option C is there now, which is having perfectly the things that we got in the final answer. So what is your answer for this? Option C is your answer, because carboxylic acid and nitro group, as here we are discussing right now. So hope this is also clear right now. If the things are clear, just mention clear in the chat box, everyone. Yeah. After this, let us discuss few more things. 1 minute. Let us see few more things to be discussed here. Can you try this question? Can you try this question? An alkene C6H12 on ozonolysis give acetaldehyde and ethyl methyl ketone. What is the product formed when X reacts with HBr? So easy question this is also. If you have watched my previous session where I have discussed this question also along with the concept that is required for answering this. So if you are unable to answer this, I will be explaining anyways, but if you want complete information, you can watch my previous sessions on this hydrocarbons, okay? In the live playlist you can watch, okay? Say an alkene X, okay, which is having C6H12 formula, on ozonolysis gives acetaldehyde. What it is giving? Acetaldehyde, CH3COH, okay? So and a methyl ethyl ketone and a methyl ketone, okay, this thing, okay. Now what is a product formed when this X reacts with HBr? So first of all, in order to answer this question, you need to know what is your this X compound in the given reaction. So it is easy now. Ozonolysis means the given alkene will be breaks into two equal halves, right now. So it means just add this carbon to this carbon, that's it, that is your X here. So write this CH3H and remove oxygen, connect them, ethyl, methyl, that's it. This is your compound X, okay. So this compound X is now treated with HBr. See, simple now, compound X is treated with HBr means H plus and Br minus. So here this is an acid, it releases H plus ion taken by this double bond alkene, right now. So this pi bond will be taking this H plus, but where will be getting a positive charge? See, hydrogen will be taken by this double bond from this side, and this is a tertiary carbon generating, so positive charge here, there we can add this bromine, so that you will get your answer like this. Ethyl, methyl, hydrogen, CH3, this newly added hydrogen here and that newly added bromine here, that's it. This is your final product. It follows Markovnikov rule addition. I hope you know that what is Markovnikov rule, anti-Markovnikov rule type of additions, right now. So now tell me, here this is your product. Where do we have such option here in the given question? See, this ethyl means you can write ethyl as CH2 CH3, right now. This is what ethyl means. So you have 1, 2, 3. At third carbon you have bromine and methyl 4, 5. Okay. So 1, 2, 3. At third carbon you have bromine and methyl 4, 5. Yes, your perfect option for this is option A. Okay. So hope you got complete clarity on this kind of questions. Like they will make a chemical formula and they will ask us to identify the products formed like this. Okay. Right. Guys, I hope you are really clear with the concept. If this is clear, just click on like button. Next. So try to get the answers for them. If you are unable to solve these questions, you can watch my previous sessions on hydrocarbons. Okay, these are the questions I am giving you. Just pause the video, try to get them. If not, you can pause. You can watch my previous sessions. Okay. Now look at this. Ethane is given, C2H6 is given, and they are saying red hot tube here, red hot iron tube. Now what happens here? So ethane means you can write like this. This is called polymerization reaction. Okay. So you just take 3 moles of this ethane. So 3 moles of ethane undergoes trimerization or cyclization, like polymerization takes place. So just write the 3 acetylenes like this. Now what happens is a cyclic ring is formed here like this. So how many carbons are there? 1, 2, 3, 4, 5, 6. A 6-member ring is formed with a conjugative pi bond. See, 1 alternate sigma bond and again pi bond like this. This is nothing but our benzene right now. So acetylene undergoes polymerization, particularly trimerization, and gives benzene as your product. So what is our A here? Benzene. So this benzene undergoes substitution reactions, aromatic nucleophilic electrophilic substitution reactions. Okay. See, it is given as acetyl chloride with AlCl3. So this chloride ion will be removed using this AlCl3 and generates a carbocation, I mean acetyl carbocation like this, that we can say acylium ion. Okay, so how it is generated? Just see here, whenever you are having chlorine here, if you are treating this with anhydrous AlCl3, we know AlCl3 has one vacant orbital, so act as a Lewis acid. To these lone pair electrons of chlorine is donated, and now there is a bond between chloride and this aluminum. Finally, chloride will take this sigma bonded electrons towards itself and generates a cation electron deficient compound like this. This can be our electrophile in this further reaction. So now this pi electrons of benzene is donated here and gives COCH3 type of product. Okay. Now what they are asking, what is the electrophile is involved? What is the electrophile involved here in the reaction? Yes, this is your electrophile involved. Hope this is clear. And the next one more thing, what is the product formed here? Yes, this kind of product is formed in the given reaction. Okay. So now in the exam they may ask what type of product formed or what type of intermediate involved or what is our A here, they may ask like benzene, like this they will make the questions. Okay, right. Next one here, yeah, look into this question again. If you are unable to answer this, you can watch my yesterday's session on this hydrocarbons discussion, because clearly explained there itself. Okay, right. In the next here, I just want to discuss few more things. Like this I am taking alkyne. So alkynes, upon treating with KMnO4, with what? KMnO4 in acidic medium. In which medium? Acidic medium I am treating. So what to do here? Just break this double bond, see, triple bond. See, again I am writing it clearly so that you will have no confusion. See, CH3, C, triple bond C, H. Okay, hot KMnO4 or acidic medium. KMnO4 you are taking this in the acidic medium. Okay, you are taking in the acidic medium. Now what happens, tell me with this? So just break this triple bond like this, okay, and convert wherever you are breaking, now there you insert OH groups. How many bonds you are breaking? 3 bonds. Now you can insert 3 OH groups like C, OH, OH, OH. But you know, on one carbon, if this many OH groups are present, there will be lone pair repulsions will be observed. So that what you can do is, you just remove water from here like this, so that you will get CH3, C, double bond O, OH, like carboxylic acid is formed. Okay. In other ways, what I can say, how many 3 bonds you are breaking now? So 2 valencies of this carbon is satisfied by oxygen, and one more valence is satisfied by OH. That's it. This is the product formed. That is nothing but acetic acid only, na? So this is how you can simply understand the concept of this oxidation of alkynes using hot KMnO4. Okay, this is one product. Now what about that side carbon? See, to this carbon, 3 sides like these are there now. So there you can insert OH, 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 like that we can remove water molecule and you will get the carboxylic acid. Now this side carbon, I mean this side you have a hydrogen now. If there is any directly attached hydrogen, convert that is into also OH group. So therefore how many OH groups comes here? So you will get OH this side with respect to hydrogen, OH, OH and OH. So now try to remove water molecule, possible number of water molecules here. Like this if you remove, so you got 1 oxygen, second oxygen, carbon. So that is nothing but CO2 gas is evolved here. Okay, this carbon is now converting into CO2. Okay, right. Next, hydrogen giving water molecule. How many moles of water molecules are formed during this complete process? 1 from here, other from here, 2 and 1 more from here. So 3 water molecules are produced, 3 H2O. So this is how you need to write the reaction. Okay, hope this product formation is clear right now. And the next, this is the very simplest way you can make your answer. Okay, and the next here, ozonolysis reaction they will mention. See, if they simply mention ozone and water, what I am saying, it's ozone and water. So what you need to do is just wherever we have double bond now, convert triple bond now, convert that into carboxylic acid. Just break it and write this is CH3 CO OH, and this side also hydrogen is there, hydrogen as it is HCOOH. This kind of product will be formed in oxidative ozonolysis. I am not using any reducing agent here. But if I use ozone, like ozonolysis in like reducing agent like zinc, DMS is used. In that way we will get diketones. Diketones means what? Just remove this triple bond, double bond O, hydrogen. So this is what diketone is produced in presence of reducing agent like zinc. Okay, so these are the things you need to remember. Okay, I am erasing this. Yeah, these are some reactions to be remembered. Now what about hydroboration? If you treat this with B2H6 in presence of H2O2 and NaOH. Now what happens here? See here, hydroboration we discussed during our alkenes chapter also, alkenes discussion also. So now what happens here is just hydroboration in presence of basic medium is nothing but we need to add one hydrogen and one OH. So where to add this hydrogen and this OH? This is simply follows anti-Markovnikov rule addition. What I am saying? Anti-Markovnikov rule addition, that is nothing, just look at here. See, first of all we need to add hydrogen, means see actually that should be taken like this, BH3 and H, like this we need to take. So if you are opening ring like this, you are going to get a secondary carbon here. That's why you are need to add OH group on this carbon. Wherever we have more number of hydrogens, now there you can add OH, and the other carbon you add hydrogen, so that you will get CH3, C, H, double bond, C, OH, H. This is what anti-Markovnikov rule addition here. And after this, this is enol now. So keto-enol tautomerism takes place to give a final product like this. See, CH3. After that, this is becoming CH2. After that, C double bond O H. So you will get a aldehydic type of product from this. Okay. Hope this is clear what I told you. Add the negative part to the more number of hydrogen containing carbon. See, out of these two carbons, this alkyne carbons only, which carbon is having more number? Here 1 hydrogen, here 0 hydrogens. So you need to add more number of hydrogen containing carbon, to that you add OH. Okay, you added OH. Here you add H, so that you will get this kind of product right now. So now this is all in keto-enol. Enol will be undergoes keto-enol tautomerism to give this kind of final product. So this is your final product during this reaction. Okay, so this is in which medium? Basic medium. Okay, which medium it is? Hydroboration in presence of NaOH, H2O2 and NaOH. Remember this is in a basic medium. Okay, right. Clear now? Yes guys, if things whatever we discussed till now are clear, just mention clear in the chat box. Do you have any confusions in this discussion? No, right? So all these discussions whatever we did, these are very important for your exams. Okay, for your competitive exam, whether maybe JEE, NEET or EAPCET, these reactions are very important. See, to the same compound, I'm asking you one more question. Just tell me what will be your answer. So you need to add water in presence of HgSO4. Okay, and dilute sulfuric acid also mentioned. What is your answer? I am mentioning this as a D. What is your D? Tell me its IUPAC nomenclature in the options, I mean in the chart box. What is this D product formed from this alkyne during the reaction? So tell me the IUPAC name of this D in the chart box. Okay, hope if you answer that question, I will definitely consider you have followed this session very effectively without having any confusions, because these questions like this model questions we did 2-3 questions we did in this session, and in the last session I have clearly explained how that is happening also. Okay, right now next, anyone any questions in the chat box to be asked? Anyone? Deepak sign in the chat box, or anyone having any doubts? So you can take a screenshot. Yes. One more type of reaction, this is very important. See, whenever there is an alkene, okay, like double bond. So double bond is there means, see, simply if it is like this, and if the temperature is not mentioned, like if they are mentioning here, if they are mentioning here CCl4, something like that. So what happens is chlorine will react wherever double bonded carbons are present. It means on these carbons only, double bond carbons only, you need to add hydro like chlorines, whatever you need, they have given, you need to add here itself. It means I will tell you two reactions here, so that you will get complete clarity. But because in organic chemistry, the more like main thing here, most of the students confuses like what type of reaction is taking place in with a particular reagent. Look at here, one simple example I will give you. See, simply if they mention like this, C triple bond, C double bond, C, H and H2, like this, a given alkene treated with CCl2 in presence of non-polar solvent like Cl2 in non-polar solvent like CCl4. So tell me what is your answer, they may ask here. So if you see, this question is also looking like same now, same substrate, same reagent, but reaction conditions are different. Reaction conditions are different here. So whenever they are mentioned like high temperature like 500 degrees Celsius, or sometimes they may mention sunlight, H nu, like that. So now what happens is, this allylic position carbon is there now, this allylic carbon. So there substitution of chlorine takes place. When I am saying when it is high temperature or sunlight is there, means this allylic, see, this double bonded carbons do not disturb. To that adjacent carbon is there now. So on that carbon any hydrogens are present, that hydrogen will be substituted by chlorine. Okay, so one of this hydrogen is substituted by chlorine, that is what you got, allylic chloride. What is that? Allyl chloride. Okay, same story applicable when you have a benzene ring. See, benzene ring is nothing but these pi electrons are nothing but, here you can write like this now, 1 2 3, like this we can write now. So this double bond carbon to this adjacent carbon is this one only now, similar to this whatever we discussed. So now here 3 hydrogens are there. From these 3 hydrogens, one hydrogen will be substituted by this NBS. What is this NBS means? N-bromosuccinamide. It is a brominating agent. It means it will provides bromine radical. That radical will be substituted over this carbon, on this carbon, by removing hydrogen radical. Okay, so that you will get a benzyl radical. Okay, now same reaction also takes place in the other manner also. Let me show you. See here, they will give like this CH3, and they will give 3 types of reagents. This is very important and most commonly asked question in JEE. So they will mention Cl2 in presence of sunlight. Now what will be the product? See how many hydrogens are there here? 3 hydrogens now. So we can replace one hydrogen and you will get this benzylic chloride. What you will get? Benzylic chloride will be your product. Okay. Now sometimes they may replace 2 hydrogens and you may get CHCl, Cl type of product, same reagent. Sometimes all 3 hydrogens are replaced and you will get CCl3 type of product. So this is A, B, C. These are the 3 possible products. Now how can we identify then which is the correct answer? You need to look at the further reactions. If they mention only up to here, they particularly mention one of these options. They won't mention 3 options as your answer, because 3 are possible here. Okay. If they wanted to mention like this, so they will give a continuous reaction here, so that looking at the final product formed, we can decide what type of intermediate is formed. Let us say this is A, B, C. Okay, these are the 3 things formed. Now the final product that is coming from A, when I am treating with aqueous KOH, will be looks like this. See, wherever you have chlorine, replace that chloride with this OH, benzylic alcohol will be formed. So here 2 OH groups if you remove, you will get an aldehyde, benzaldehyde will be produced. Here you will get a benzoic acid. Okay, so it means the final product, by looking at these final products, we need to decide our intermediates A, B, C, which is our perfectly formed intermediate. Okay, hope this discussion is also clear. One of the very commonly asked question in JEE, even in EAPCET or NEET also you can expect this kind of model questions. Okay, hope this discussion is clear right now. No confusions, right? Right. If no confusions, it's really good. Now, if you observe this one, what they have mentioned double bond chlorine, but here it is CCl4. This is a non-polar solvent now. So in non-polar solvent, this chlorine will directly attacks on the double bonded carbons, like a halonium ion mechanism takes place, and here one chlorine, and gives CH3, CH2. You can add one chlorine here, other one here. That's it. This is your final product for this question. Okay, right. Hope complete discussion of this session is clearly understood or clearly followed by the students, those who are watching it live, and also might be recorded someone. Okay, so if you really like the content, just click on the like button, and you can share your feedback in the chat box. No worries, if you have any concerns also you can mention. We will be covering them in the upcoming sessions. So all the best. Thank you for watching. Thank you.